Okay, guys, welcome back. Today we're going into the first day of the Unit 2 packet. Our theme for this unit is going to be functions, equations, and graphs. We're going to start off with Lesson 1. This video will cover the first half of Lesson 1. I'm going to break up Lesson 1 into two separate videos. So let's scroll down to page 3 and hit up Lesson 1. Don't worry about the warm-up. That's more if we were in class live. We're going to skip that for the video. So our first theme in 2.1 is we're going to be talking about relations and functions. It doesn't show it here, but the definition for a relation is just any set of ordered pairs or any set of points is a relation. Now, there's some other definitions, domain and range, which you guys learned in Algebra 1. The domain are the set of x values, also known as the set of input values. The range is the set of y values, also known as the output values. So example 1, we're going to identify the domain and range of the following ordered pairs. So when the directions say identify, that means just list them, okay? So in A, we're going to put D for domain and R for range, and then we put them in curly brackets separated by commas. So the domain values will be the first x values here. So -2. 6, 8, 10, and 2. Some teachers have a preference for them to be in numerical order. Me, I don't have a problem with it not being. All right, now the range values, 0, -4. This 0, do not repeat it. And then 11, and then another 0 that we don't repeat. Okay, letter B. The domain are the numbers on the left, -3, 0, 4. And the range are the numbers on the right, -2, 1, 7. So domain left, range right. This is called a mapping diagram, but by the way, letters B and C are both mapping diagrams. Don't worry about the arrows. We'll talk about those more once we talk about functions. We're not necessarily talking about functions yet. So the domain on the left, just list those numbers, -5, 2, 3. Don't repeat that other 2. And then the range values, 8, -1, and 0. By the way, I want to take a side note here. Look at this too. If you were making a mapping diagram, you would not repeat those 2's. So that's actually an incorrect diagram. Okay, example 2. The directions are identify the domain and range of the graph. So again, identify means we're just going to list them. So the domain, by the way, when it's a line or a curved graph like this is called continuous, meaning it's not broken up into pieces. If it was broken up into pieces, it would be called discontinuous. Now, for the domain, keep in mind we're talking about x values, so your focus needs to be the x-axis numbers here. Okay, so look at those numbers for the domain. So we look at the coordinates here. This would be the leftmost point right here, and that's the rightmost point. So the leftmost point traces down to the x-axis at -2, and it goes to +2 on the x-axis. Now, I am going to put a squared bracket because there's a closed circle. That means it includes the -2. The positive 2, however, is going to get a parentheses because this side has an open circle. Now, what I just did is I wrote this in what's called interval notation. I did not choose the inequality notation, which you might see elsewhere with inequality symbols. Other teachers like to use inequality notation as well, but I think this interval notation is much quicker. All right, let me erase this so we can clear it up for the range. Now the range are the y values. So the y values. So we're focusing on the numbers on the y-axis. So for the domain, let me go back to the domain for a second. The domain is the leftmost number to the rightmost number. The range will be the lowest number to the highest number. So the lowest would be right here. That would be -3 on the y-axis. And it goes up to here at 5 on the y-axis. The -5 up here has an open circle, so it gets parentheses. On the down here at the -3, however, there is no open circle. I know there's not a closed circle, but still it is touching the -3, so that will get the squared bracket. All right, and that's how you list or identify the domain and range of a graph. So let's get some more practice in. So letter B, the domain. Again, we're focused on the x values. So right here, it goes from -2 to 3. -2 to 3. And they both get squared brackets because they're closed circles. Now the range. Remember, the range are the y values, lowest number to highest number. And so again, we're focused on the y-axis coordinates. So here it goes down to -4, and it goes up to 4. Letter C. The domain, again, the x values. We want the leftmost number to the rightmost number. So that would be -4. And then goes to the right to 3. So now the y values, the range values, lowest to highest. So -2, and then up to 4. Letter D throws in a new trick here, a new aspect. Notice up here, we have an arrow, means it goes on forever. So you're going to see what happens for domain and range with that. It has to do with infinities. So for the domain, again, look at the x values, and we're thinking left to right. Left, it's going left forever. So don't put -5. We actually put, it's going into the negative territory forever. So that would be -infinity. It's going to the -infinity, where the negative numbers forever. And whenever you have an infinity, don't put a square bracket. It actually gets a parentheses. And then how far to the right it goes? Right here at 3. Now on to the range values. Focus on the y-axis numbers. So think lowest to highest. So it goes down here at -2. And technically, a lot of people put 4, but it is going up forever. So it's going up to the infinity numbers. Up to the infinity numbers, with the parentheses always for infinity. Letter E. The domain, x values. So -4 with an open circle, so parentheses, and then it goes to 3, close circle, bracket. And then the range left to right. So focus here on the y coordinates. So that would be down at -5 with an open circle, so parentheses, and it goes up to 2. There is no open circle, so that means 2 is included, so 2 gets a bracket. The only time, to clarify, the only time you use parentheses, there's 2 times. If it specifically has an open circle, or if it's part of an arrow going forever to infinity. Either infinity. Letter F, the domain, x values. So the leftmost number is -4. And to the right, that is an arrow here, so it is technically going to the right forever towards the positive infinite numbers. And put a parentheses. So pretty easy stuff so far. Today's a very easy lesson. And then the range values. So lowest to highest, y value this time. So focus on the y's. So the lowest is actually right here at 0. And then highest, that remember we have an arrow, so it is going up forever. So infinity also. Okay, I want you to pause here and try letter A and B and C on your own. So pause the video, try them on your own. Okay, let's see what you got for identifying the domain and range. So the domain you should have had, put it in curly brackets, 8, -2, -3. Do not repeat those 8s. And then the range, 4, 7, 8, 0. Now pause, if you didn't already, pause it and try letter B on your own. Don't just wait for me to do everything for you. Always make sure you are trying and attempting math. Math is by doing, not just watching. Okay, so the domain, it's going left forever and right forever. Those arrows. So the domain is -infinity to infinity. And then the range, lowest number to highest number, y values, it goes as low as -1, and then it's going up forever. Arrows are going up forever. So -1 inclusive to infinity. And letter C, the domain, the x values, it goes from -3 to 3. And then the range, low to high, that would be from 0 up to 4. 0 to 4. Give me 1 second. I got to look for my stopping point. Okay, and then the last part of part 1 of this lesson is the term function. The definition for a function is a relation in which each input has exactly one output. So what does that mean? imagine if you had an equation and you were putting x's in it. Is it possible to put in a number and get two separate answers? No, you can't input one number and get two separate answers. It doesn't work like that. So in example 3, we're going to determine if the relation is a function. So when our directions say determine if, that always means we're looking for a yes or no answer. So what we're going to do here is focus on the domain values. So in number 1, notice that 3 goes to one answer, -2. 0 goes to one answer, 7. And 4 goes to one answer, 1. So that would be a yes, that is a function. Every input has exactly one output. So let's take a look at number 4, another mapping diagram. -9 goes to one answer. 3 has one answer. 5 has one answer, 21. And 11, however, goes to two different answers. 11 is going to -2 and 8. That is not allowed. This relation, we would say, is not a function. Okay, let's try a set of ordered pairs to determine if it's yes or no, a function. So here I look at the x values. I got a 3 and no other 3, so far so good. I'm looking for, by the way, I should say, I'm looking for any x values that repeat. -2, does that repeat? No. 4, does that repeat? No. -1, does that repeat? No. 8, does that repeat? No. None of my x values that I highlighted here repeat. That means this is going to be a function. We're looking for repeating numbers to see if they have two different outputs. Let me give you a side example here of two things that would not be a function. If you had, say, 3, 0 and 3, 7, this would alert me of not being a function, because you can't have a 3 have an output of 0 and a 3, the same 3 having an output of 7. So that would not be okay. Number 5, again, I look at the x values. I'm looking for any that repeat. I have 3, 11, 121, and 34. None of them repeat, so it's automatically got to be a function. Yes. Number 3 and 6 are graphs. We can tell if something is a function or not by using what's called the vertical line test. And what it states is if you drew a vertical line straight up and down, if it would cut through more than one point on your graph or intersect more than one spot on your graph, it would not be a function. So number 3 is actually a function. It passes the vertical line test. If you drew any vertical line anywhere here, it's only intersecting it at one spot each time. 6 is an example of not being a function, though. If I drew a vertical line, say here, it would cut through more than one spot. So not a function. Okay, guys, that concluded part 1 of lesson 1 of unit 2. At this point, we did a bunch of things today. So if you take a look at the homework, you guys should be good to go for numbers 1 through 9. We covered everything for 1 through 9. All right, guys, have a great day.